Konnichiwa minasama, Jérôme Altunian desu. Yoroshiku onegai shimasu. I joined TDF 10 years ago, and I'm now in charge of decommissioning and waste management activities for Asia, with a strong focus on Japan. First of all, I'd like to apologize because this presentation is not dedicated to the regional development, but we will try through this presentation and the next one to explain the link between the decommissioning and what kind of impact, positive impact, it can bring regionally. So through this presentation, I'd like to provide a short update of EDF decommissioning project in France. And I'd like also to emphasize the link, the close link between decommissioning and waste management. So what is at stake in France for EDF? First of all, EDF is, as per law, in charge of the end of life of its own reactors. We have to complete the decommissioning of 11 reactors that are already shut down. And to do so, the waste is a key issue. Then we have to innovate, and we have to develop industrial solutions to secure all the necessary waste route for our decommissioning project. In addition to the units that are already shut down, EDF has to actively prepare the decommissioning of the rest of the fleet. As you may know, in France, we have 56 operating units. All of them are PWR. This new program will be based on some first lessons learned that we have acquired with our current project. To mention some of them, technical scenario, so best strategy, and technical choices, the processes that will be used, the budget, because we must have the better optimization possible, human resources, of course, and last, and I think it is directly connected to the regional development, we must have a robust supply chain with reliable partners and suppliers. Last, of course, it is a growing market. It's not anymore an emerging market, but when we talk about decommissioning, that's a reality in Europe. A lot of units have been shut down, and now we have to deal with this heritage. And that's the reason why EDF is also supporting other nuclear operators through some cooperation agreement, but also thanks to a new subsidiary that has been created recently named CycLife. And you will have another presentation to explain what it is about. So, a couple of words about our internal organization. Within the thermal and nuclear division, we have two entities that are dealing with decommissioning and waste management. DP2D, basically in charge of the delivery of the French decommissioning project. So it's a project mode organization. And CycLife, on the right-hand side, CycLife, created in 2015, is offering a wide range of services in order to secure our own project, but not only. And we will detail it later with waste management solution, also dismantling engineering, and new processes, technology, and digital solutions. Today, the proportion is half EDF and half external customers. So CycLife, what it is about. First of all, it's a set of subsidiaries with a strong footprint in Europe, as you can see. Three strategic business areas. The first one, and it is historical, is waste management and waste treatment. We have three subsidiaries in the orange box. So you can see here one subsidiary in the UK, SiteLife UK, one in Sweden, and you're going to have a dedicated presentation right after, SiteLife Sweden and SiteLife France. What do? We provide services for optimizing the waste strategy. Just to mention the main ones, we have simple treatment options such as waste volume reduction, blasting, but also some more complex projects dealing with metal melting for scrap metal or large components. Also incineration of liquid waste and solid waste, and some other more specific services such as mobile machine that could be placed on one site or another site, for example, to treat used resins. The second area is dismantling engineering. You can see Graphitech here and SiteLife Engineering. The purpose of these subsidiaries is first to design the best and optimized strategy for dismantling scenario related studies. Graphitech, of course, for graphite reactor, and I have to say that it is a joint venture with Veolia, and SiteLife Engineering for light water reactor. So they design the strategy, they perform the studies, and they also work on the set of tools that will be required for doing the operations. And of course, it is directly focusing on remote cutting tools, because this is probably the most difficult part. Last, I'd like to mention also the digital, because it is a reality, and because we have invested. We have two subsidiaries. You can see Quadrica and SiteLife Digital Solutions. We are covering all the data value chain, and we can provide different services and studies. I can mention virtual reality, digital twins, 3D scenario, and we have also a software that enable us to benchmark different scenarios to find the optimum. So short introduction to the, let's say, decommissioning map in France, only for EDF. As you can see, we have 11 reactors shut down under dismantling, 4 different technologies on several industrial sites. If I detail a little bit, dark green, you can see Brennilis in Brittany. Then you have the graphite reactors, 6 units between Saint-Laurent, Chinon, and Bugey. You have on the top of the slide 3 PWR units. The oldest one, Chaux, in Les Ardennes, and 2 units on Fessenheim, because, as you know, it has been shut down a couple of years ago, in 2020. And last but not least, Cresse-Malville, also known as Super Phoenix, which is a fast breeder reactor. Today, in 2022, we have around 15 years of experience, because the program started in 2007. And thanks to this program, we are also working to plan the best strategy for the rest of the fleet. And this is a key issue today. So, update on 2 technologies, as you may be interested in Japan. First of all, PWR. As I just mentioned, we have 2 plants. The oldest is Chaux-A. Chaux-A, 300 megawatt, for which the decommissioning decree has been granted in 2007. The completion rate is around 80%. We have almost completed the dismantling of the primary circuit. The internals have been completed last year in 2021. It was an underwater scenario, and today we are preparing the cutting of the vessel itself. That's the first of a kind for us, and it's a unique opportunity to learn, to acquire experience, and then to design by learning the next scenario, the one of Fessenheim. Fessenheim, as you can see on the project timeline, it has been shut down 2 years ago, and the decommissioning decree is expected in 2025, which means that today we are in what we call the pre-dismantling phase, consisting of defueling the plant, also doing a full system decontamination of the primary circuit, and a very key project, and we will talk about it more in detail later, the removal of the steam generators. And of course, we are actively preparing all the operation regarding the decommissioning phase. All in all, if you start the counter in 2025, the time where we will get the authorization, we intend to complete the project by 2040, which means that in 15 years, we will have completed the decommissioning of 2 PWR units. That's the challenge, and this is what we have written in our decommissioning plan. Next project on the right-hand side is Super Phoenix, a fast breeder reactor. It's a very specific and unique plant, unfortunately stopped, I think, too early, but it's an opinion. Just to give you an order of magnitude, the size of the vessel is 20 times bigger than for a regular PWR unit. So technically, it's a big challenge. And where we are today, so the progress is around 70%. A big operation has been completed. We have removed and treated all the sodium, so the bulk sodium and also the residual sodium, which was a key step. And then we can say that there is no longer any risk related to sodium-water reaction. Very recently, last summer to be precise, we have opened the last 3 plugs on the top of the vessel to access the internals. And by doing so, we are now able to prepare the next phase, and we are installing a remote cutting and handling facility because all the operation will be done remotely. So to share with you a couple of lessons learned among everything. First of all, I think it's very important to explain that we have gathered a lot of lessons learned, some good practices, but also some choices that we would make differently if we had to restart or if we consider the upcoming project. So it's very important to learn from what you have done, and this is the case within EDF, and we really pay attention to that in our next scenario. So maybe three short focus. The first one has been well explained by Mr. Yamauchi. That's the first one. So I fully agree. I think about human resources, the first question is, what do we have to do and with whom? And the first conviction is to say that operating a plant and dismantling a plant is really, really, really different. What we will need in the decommissioning phase, we will need new skills, we will need new technologies, we will need also a new organization, a project mode organization, which is far different from what we have in operation. I think we can say that the mindset, the cultural mindset is really different. And we can't just take the current resources and organization and just ask them to dismantle the plant. It doesn't work, and we have experienced. So this fast-moving environment has to be anticipated. This is the first message. Then the second one is about the difference from one design to another. when we have started some years ago, we made an international benchmark to learn from the other country, USA, but not only, in order to choose finally the best scenario. And we decided to go for an underwater scenario for the vessel. But finally, a couple of years later, and this is true for graphite, we have faced major technical challenges that forced us to reconsider our strategy and to shift. We wanted to do it underwater, and finally, for some reasons, including the risk of corrosion after years and years, we decided to shift. And then the strategy implies a lot of things, including the construction of what we call an industrial demonstrator with some partner, and it has been also mentioned in the European project. It is also a source of creation because we're going to create jobs in the country in order to secure this new strategy. Globally, we will design the scenario, the detailed scenario, and we will work to develop all the tools. And I would say this is not a piece of cake. For those who have visited a graphite reactor, this is just huge compared to a regular PWR unit. So that's the second lessons learned. And just to say that if we consider the planning and the cost, it may differ with a factor of 4 between a graphite reactor and a PWR. So it has nothing to do. And last, that was the topic of this presentation, what we call the waste-led decommissioning. It has to do also with the mindset and the strategy in decommissioning. To keep it simple, the idea is to define as soon as possible the waste strategy, and this waste strategy will drive the decommissioning project. We must know what we have to do, what kind of waste, and what's the plan. So to do so, it's, I think, pretty obvious. We need a robust initial inventory. We need to know the volume. We need to know the type of waste. We need also to understand the radiological inventory of our waste. And once we have done that, we must define the waste route, including some waste treatment or waste optimization options up to the final disposal. That's, I think, a very key message. In a nutshell, what we used to say is that dismantling means producing waste. A concrete example is about the steam generators in France. At the beginning, for show A, we decided to remove the component in one piece, what we can call a rip and ship approach. We take the component, we take it out of the facility, and then we treat it somewhere else. By treatment, I mean decontamination. And then we send it directly, we send it for direct disposal. That was the plan, and that's what we did, but that was a bad idea. That was a bad idea for two reasons, two main reasons. First of all, it was really complicated to decontaminate the component because we wanted to reach the weight acceptance criteria of the final disposal, and it has been really difficult, not to say more. And the second reason, now we have the conviction that sending such a big component in one piece for final disposal, it's probably not the most optimized and sustainable option. So this is not what we're going to do for the upcoming project. And for Fessenheim, that will be more or less my conclusion. What we plan to do is to keep the rip and ship approach. So we're going to take the components out of the plant, but we will send them in a dedicated metal treatment facility in Sweden for cutting, for melting, and for recycling. So that's a key learning, leading EDF to invest a lot in the supply chain to secure all the needs on waste management. So to conclude, a couple of, I don't know, maybe convictions. What we call the waste-led decommissioning will contribute to a better efficiency on the project, less operation on site, no need to build a new workshop inside the facility, which is quite strange to build new workshop when you have to dismantle the facility. Will contribute also to reduce the risk, less interfaces, and a better control of the planning. Budget optimization, because less waste means less disposal cost, which is quite obvious. And finally, maybe the most important contribution is to save the natural resources, because we won't have to build new disposal facility. And that's it.
Thank you very much.
Thank you very much.
So one question from the audience. So his question is, graphite reactors decontamination in France is not very fast at the moment. Do you have any reason or current status to speed up the decommissioning of graphite reactors? You have 6 graphite reactors under decommissioning.
Yes, I'm sorry, I did not describe exactly what is ongoing regarding graphite, but I briefly explained that we had a strategy. I can say more or less immediate dismantling. So you start the dismantling as soon as possible. But finally, it was not easy for some reasons. First of all, we have no final disposal for graphite waste. So being consistent with what I have explained, it's difficult to start when you don't know how you will do what you will do with waste. And the second point is about the strategy. We wanted to go for an underwater strategy, but after years and studies, finally we had to change. And now the new strategy consists of building a demonstrator, to work with other partners that have the same problems or the same challenges, and then all together to consider how to do it. And the most, what we really want to do in the short term is to find both the scenario and the tools that will be used during the dismantling of the plant. So I'm not answering the question regarding the graphite waste, but if you look at the project schedule, we are not starting anything right now. We want to demonstrate that we know how to do before starting the real dismantling, the actual work.
Another question is very similar to the question, how do you treat the waste of graphite containing carbon-14? So maybe at the starting point.
I'm not a specialist.
Okay, thank you. Okay, so following the Jérôme-san, I want to invite the next speaker, Mr. Arne Larsson from Sweden. His presentation title is Management and Treatment of Retired Large Components. So thank you, Jérôme-san.